Hi, good evening all. Welcome members and guests who is attending today's event. So we are back again on our online sections. So I like to say that from next month onwards, we are planning for hybrid meeting where we will be having face-to-face and online section as well. So we will try our best to do that process without any errors. Last year we tried for 2 months, so we are back to do that again. So I believe from next month, September and October, we will be doing hybrid section. And again, November, December, we have to go back to online section. What will be happening? It will be difficult for members to travel. Then again, from January, we will go back to hybrid section as well. The members attend the session. If it is possible, please come and attend the face-to-face session. So I encourage you all to attend the session. So we can see each other's face-to-face. So for today's section, I'd like to introduce Mr. Jawahir Hamza. Like, I'm so happy that he accepted our invitation to present on this webinar. Actually, I've been trying to get hold of him from last 1 year. And for this month, actually, we're supposed to have our meeting last week, but the speaker which has been arranged and who's supposed to deliver last week has been packed with other work and he couldn't able to deliver a section. That's the reason we have postponed the session to this week. And thanks to Jawahir, he saved this time and he said yes to deliver the section. And in a week time, he was here with the presentation. So I like to introduce Jawahir. He's a UPDA approved Qatar Civil Defense certified fire alarm engineer. He has over 10 plus years of combined experience in oil and gas, energy sectors, production industry, and other commercial sectors as well. Currently, he's handling the role of senior maintenance engineer with Qatar factory Nfpa. So that's Jawahir. So he'll be delivering section of National Fire Alarm and Signaling Code. So Jawahir, thanks a lot. So the stage is yours.
Thank you, Deepu, and thank you, Julie, for this opportunity. So myself, as Deepu introduced, I am a UPDA approved engineer, and I'm also a Qatar Civil Defense approved engineer as well in fire alarm systems. So what we're going to discuss is it's basically an overview of the NFPA 72. So the NFPA 72 is the National Fire Alarm and Signaling Code. The editions actually that we have referred to here is the 2016 edition and 2022 editions. The 2022 editions has a few variations that have been included with reference to 2016. I believe that is mainly the inclusion of cyber security into fire alarm systems as well. But because the code itself is very vast to be discussed over a short session, we will be trying to brush up the overview of a fire alarm system, how from a safety perspective, what someone who's familiar with the fire alarm system or who has no familiarity at all with the fire alarm system can interact with the system. Okay. First of all, before beginning into it, I would like to start with mentioning the AHJ. What an AHJ is basically is the authority having jurisdiction. So when we say NFPA 72 is a code for fire alarm systems, that is not the final say on anything. It is only a guideline. So what we need to know is it acts as the guideline for developing any new systems, which is a fresh building or a fresh industry or whatever be it, any place or environment which needs a fire alarm system protection, you refer to NFPA 72 as the guideline. And also when you are going for a modification of the system again, you go for the NFPA 72. But this is all based on whether or not it is approved by an AHG, which is the authority having jurisdiction. So the authority having jurisdiction or the AHJ, which if we are referring to AHJ in further conversations, it will be AHJ. They have the final say on whatever requirement has to be followed based on their codes and guidelines. If we are looking for Qatar, Qatar has QCD as its AHJ, which means Qatar Civil Defense has its own code lines, codes and guidelines, which are based for each system. It's not just fire alarm system. It can be a fire protection system. It can be for fire pumps, the methodology of how to do inspections on fire extinguishers. There are codes for each of these. So for the fire alarm system alone, QCD will have a specific guideline. So those have to be followed. And there will be instances wherein the AHJ doesn't cover the whole scope of whatever we are looking at. Maybe they don't have a particular code or guideline where we don't have any reference to. This is where NFPA 72 comes into the front. So there, the go-to reference for somebody who is designing or who is doing the maintenance, or from a safety officer who has to see that whether the contractor is doing the maintenance correctly in the right sense, has to just refer to NFPA 72 if the ASJ doesn't have a specific guideline. Okay, now the scope, as in for the code NFPA 72, the NFPA 72 covers the application, the installation, location, the performance, the inspection, testing, and maintenance of fire alarm systems, supervising station alarm systems, public emergency alarm reporting systems, fire and carbon monoxide detection systems, and warning equipment and emergency communication systems and their components. So what it means by this is the application, as in what type of system you need to apply for a particular building. That itself is being covered in its code. How to install this particular system and where to install the devices, which we'll go into further detail during the next slides, like what type of devices there are and how they should perform and how an inspection is to be done and the frequency of testing as well as the maintenance aspect of it. So the purpose of this whole NFPA 72, again, it goes back to identifying, like it goes to understanding how the signal should be initiated, the transmission of signals, and how a notification should be raised, how an annunciation should be raised, as in when at the user end, at the end of it all, when a fire alarm happens, you need to have a proper standard for how the signal is to be relayed from the beginning of the identification of the alarm itself, right up to notifying the people in the building on how to evacuate or what is the next procedure. Are there any other equipments which need to follow a specific guideline and those. So yeah, the code also establishes a minimum required level of performance, the extent of redundancy, and the quality of installation, but does not establish the only methods by which these requirements are to be achieved. So this part is to be focused, I would say, because there are a lot of ways this code will tell you how to improve, how to achieve the minimum required performance of a system. And the redundancy, as in, for example, if you have a power supply, what or how should the backup battery should be calculated. There are different aspects of it where the code itself has a detailed part where it is discussed. But that this alone is not the way which we can achieve it. Like if you go to an industry, like in the energy sector, for example, the way they have a redundancy will not be the same that a commercial sector building will have. For a energy sector, the difference is they will have maybe 5 or 6 redundancy, that is a backup for their system in case the system fails. So if the main power fails, they'll have a secondary power. If the secondary has failed, they'll have a tertiary power. So this goes on, and I have seen systems where there are 6 redundancies even, wherein the system basically you can say that it will not fail. But in the case of a commercial buildings and all, what you normally have is you have a primary power supply, and the redundancy will be the battery backup. So, but these are not the only requirements which I mean, these are not the only what do you call ways to establish this. There are multiple ways how the same thing can be achieved. Okay, now what I want to discuss is from a user perspective, to understand the fire alarm system. There are basically two types of fire alarm systems. There is a conventional fire alarm system, and there will be an addressable fire alarm system. So the main difference when you compare a conventional and an addressable system is it is the scale of the fire alarm system which it is designed for. As in, a conventional system is normally it is more suitable for smaller buildings like smaller offices or smaller shops, even for maybe a small individual apartment, like a small house, you can go for a conventional fire alarm. But when you go for a huge building complex or a what do you call an industrial complex, the difference is you have a huge asset wherein you need to specify and identify the specific locations of alarm. That is where an addressable fire alarm system has the major advantage, because when you compare the conventional system to the addressable, the conventional can only tell you a zone where the fire is. It will not tell you exactly which detector has gone into alarm. It will only say, for example, if you're looking at this part of the page, it will only say this part has an alarm, but we don't know where exactly it is. Maybe the fire is exactly showing on the fire part. This is where a detector has activated, but the conventional detector will not be able to point out this specific part of it. It only knows that, okay, the whole equipment, what you see here, this part as a map, and we're not talking this as the physical equipment. I'm talking this as just a guideline, okay? Um, as in, it will not help you to identify the specific location for a conventional system, but the addressable system will pinpoint the source of the alarm, as in which detector, in what spot, and the location. These all can be added as input into an addressable fire alarm system. Okay, this is the general diagram for a fire alarm system. So this is a common diagram which you can compare for both, actually, for a conventional as well as addressable system. So the main unit that we normally see for the end user is, we normally see the fire alarm control unit or control panel. So from the control unit, there are a lot of devices which are connected to the whole system. So the whole design, or the modules that you see here, these are all based on what Nfpa 72 recommends, which is it should have an initiating device or a circuit which is specifically going to an initiating device circuit. It should have a notification set of devices which should be connected to the notification appliance circuit, which is called the NAC. And you will have again, these are also initiating device circuit, which is output devices, where I mean input devices itself, wherein there are supervisory inputs being used, as in you will get the feedback of particular systems, as in if the fire pump is running, or if any particular fire suppression systems have activated. These also give the feedback to the fire alarm control unit. And in the case of emergency control functions, that is when any of these initiation devices, for example, a smoke detector or a heat detector, goes into an alarm, or somebody has manually activated a fire alarm call point, this will trigger an alarm, and the the fire alarm control unit will notify the appliances, which is create either um, an audible or visual alarm, which is through a speaker strobe, which creates a flashing light, or it will create an audible alarm through the speaker. And in parallel to it, there will be emergency control functions, wherein when the alarm is activated, you want the elevator to do a particular function, as in you don't want the elevator to be running from the top floor to the bottom all the time when a fire is happening. You either send this particular elevator to a designated floor, This is one of the requirement of Nfpa, wherein you don't want the elevator to be in continuous use. So if the, for example, let's say the fire has happened on the ground floor, the elevator cannot go to the ground floor because that is where the hazard is. So you will have a alternate level wherein the elevator can come and station it. That is an option if the ground floor is on fire. If the fire is on a level higher than that, the elevator can go directly to the ground floor where people can easily evacuate. And in parallel to this, there will be smoke control options wherein these smoke control ventilation fans will come into play, as they will suck up the smoke so that people don't end up suffocating, and the carbon monoxide and all the hazard, the toxic gases all get pulled out. So these are examples of emergency control functions. Now we go on to explain regarding the initiation devices, as in what are fire alarm initiating devices. So we need to see what Nfpa 72 is telling, what exactly a fire alarm initiating device is. It is a device used to manually or automatically signal a fire alarm system to initiate responses from equipment and people. We need to understand that this part is very important from a safety perspective, because I have seen a hell lot of times that the people within the building do not respond to fire alarms that happen, because they've seen it day in day out. They see false alarms every single time. So what we need to do from a safety perspective specifically is, every alarm is a genuine alarm. You cannot, even though you're experienced to know that this is maybe a false alarm, there is nothing called a false alarm. The system only knows that there is some discrepancy in its input, and it is identifying that there is something wrong. So we have to accept that the system is functioning as a regular in a regular way, and we have to act so that even if it is a genuine scenario, we are doing the right thing, because the equipment, if it is maintained properly, it will function. But this part is very important. So these devices that are connected to the alarm system's control panel and are under the control panel surveillance. When triggered, the control panel identifies the location and then goes into the alarm stage, sounding alerts throughout the building and sending commands to emergency responders. So what happens is, when the initiating device goes into an alarm, it being connected to the control panel will trigger the control panel's activity, as in the system itself will respond and it will trigger the alarm, and it will sound alerts. The alerts are through the notification devices like speaker, strobe, and also it will send, you can design it to send commands to the emergency responders. If you look at the types of initiating devices on the right side here, there are different types of initiating devices which we come across very frequently. So there are smoke detectors, which are the most common type of initiating devices, and smoke detectors are very effective in the scenario that it goes into an alarm actually even before you have the actual fire breakout, because smoke comes before the fire. So your detection system that can activate even before the fire has spread is something that is highly effective. This is why the smoke detector placement within the buildings are very clearly defined in Nfpa 72 as to how it should be placed for irregular ceilings, and the spacing for smoke detectors are also mentioned. So these are there in detailed sections. So I don't know how we can go into detail of it, but we'll try to cover it in whatever way we can. Then there are temperature detectors, which there are restorable type and non-restorable type. What happens with the restorable type is, if it goes into alarm, this type of detector can be restored and used again. But the non-restorable type will have a melting element, as in once the temperature reaches a particular point, it will melt the element and it creates a motion of the relay inside, and it goes into an alarm. And that cannot be restored because that is a one-time device. So once this happens, from the maintenance perspective, the immediate thing to do after the whole situation is restored to normalcy is to change it immediately. This cannot be reused. A non-restorable temperature detector cannot be reused. And for a heat detector, there are two types which are commonly seen, which is a rate of rise detector. The rate of rise detector is, I wouldn't say it is highly reliable. I wouldn't say it is that reliable because the heat in the room where the fire is, first of all, the fire has to be there, and the rate at which the temperature is rising has to rise at a drastic level for the detector to go into alarm. Which means if the heat is rising very slowly, this will not go into alarm. This will only trigger an alarm if the fire happens suddenly and there is a huge rise in temperature, which will trigger the functioning of the detector. Whereas a thermistor type of a heat detector is more reliable. And then comes the carbon monoxide type of detector. This is a very highly reliable detector because this is a lifesaver as well, I would say. If you have a carbon monoxide detector coupled with a smoke detector, this is one of the most efficient things you can have as a fire safety device at your home. And then what we have is a manually activated initiating device. You don't normally see it in regular homes, but you'll have it in apartments, in commercial buildings, in malls, in industries and all, where there will be a manual call point. Even in schools, you can see it. And then you'll have the vane water flow switch. The vane water flow switch is basically for a sprinkler system wherein the sprinkler has already functioned, as in it has started releasing the water, and it will have a water flow switch which is indicating to the fire panel that, see, a fire has happened in particular location and water has discharged, and it is indicating the flow of water due to the sprinkler. And there will be a pressure switch as well in the same line, which is connected based on the surge in pressure due to the water flow. Now, we just discussed about the different types of initiating devices as per Nfpa 72, and what we'll discuss about the different types of notification devices. The notification device are basically, you can categorize them into light and sound. So fire alarm notification appliance is an active fire protection component of a fire alarm system. A notification appliance, it can be audible, visible, or it can be any stimulus to alert the occupants of a fire or other emergency condition requiring action. I don't think this is actually in place yet, but there are suggestions for vibrating equipment also to come into place to alert people who are not responsive to either light or sound. So those are also options that are coming as an option. And audible appliances have been in use longer than any other method of notification. So this is you can see even in the oldest of constructions, you will have mimic panels which will give a light and sound and indicating that fire has happened, and there'll be horn strobes, which is a combination. So these devices have been in place for a very long time, and then they're very effective as well. Okay. As for the initiating devices and notification appliances, I would say the most important aspect of having a very reliable fire alarm system is ensuring that your system is actually designed with hazard as the focus. You never go with budget as the focus. This creates a hazard in itself. You are creating a risk wherein you are compensating for the way to protect the whole system based on your budget. No, your focus should be on the hazard, and if you are following the code with the minimal requirement, then itself the budget will come into place. And the other aspect that we need to focus is compliance towards whatever the manufacturer is listing, as in, for example, the devices will have a listed spacing on the devices itself, which is mentioned. As in, for smoke detectors, if you can say, the general spacing listed will be 30 feet. So the space between detector to detector should be at least 30, I mean, should be within 30 feet. It's not allowed to go beyond that. And for a heat detector, the range would be the listing, this is the general range, is 15 to 50 feet. So there is also another way for high ceiling, wherein when it comes to this range, the response in the detectors may be lower. So when the height increases, there is a 0.7 rule, which we call it a 0.7 rule. The 0.7 rule is basically you multiply the listed spacing with 0.7 and you will get a lesser value. So that should be the maximum distance between detectors, so that you ensure all the spaces within the elevated ceiling is covered. I hope that is clear as well. Let's move on to the what we call the inspection, testing, and maintenance, what we call for a fire alarm system. This is the terminology which we use not only for a fire alarm system, it is for fire protection systems as well. So ITM is very important in ensuring that the system is functioning to its design as per its requirement, as per the approved specs. So we'll go into each of this individually. So this is only one part of the table of inspection, wherein Nfpa 72, if you have a copy of Nfpa 72, this is based on Nfpa 72 2022. And the table which indicates the method for how to do a visual inspection and the period is portrayed in 14.3.1. This is also the same in Nfpa 72 2016 as well. There are no changes in the what do you call, in the content listing, as in 14.3 is 0.1 is the exact point. The only changes, like I said, is I think the addition of cybersecurity has come into place in 2022. Okay, now what we'll see is the visual inspection on what type of devices to be done. For example, for all equipment annually, the frequency showing annually, we need to ensure that there are no changes that affect the equipment performance. Like what we need to inspect is for building modifications, occupancy changes, changes in environmental conditions, device location, physical obstructions, device orientation, the physical damage, and degree of cleanness. So if there is any change in any of this, if there is a modification of the building, if there is a change in the occupancy change, as in if the building is supposed to be occupied by a maximum of 500 and that has changed to 600 for say, so is that allowable? Is that an allowable capacity as per AHJ? If it is 600, and then what are the changes done in the building, and are there any additional systems implemented to ensure the safety, are all to be considered. So annually, these need to be checked. So similarly, if you look at control equipment, so the control equipment will be the fire alarm control unit. So in that case, we will not actually go into all of this because this is very big. So we're just looking and brushing up what are there, just to see what all have to be done. So when you have a fire alarm system under your supervision, if you want to know if your contractor is doing his activity, if you're following Nfpa 72 as the reference, then this is where you have to go. This is where you can find if the system is in a healthy condition. Are they doing it according to this particular frequency, and is this what they're doing? So this is all the checklists and the checkpoints that they have to follow. So this is for a control equipment, fuses, interface equipment, lamps, and LED, the primary power supply. These are all to be done annually. If you look at trouble signals, because trouble signals get generated more frequently, so these have to be inspected semi-annually. That is a an increased frequency. Similarly, for fuses, interface equipment, if you have an in-house team, they are supposed to look at all of this weekly to see that the system is healthy. Now I'll just hop on to Nfpa 72 to show the same table to see what all are there, because I did not add it to the presentation. Okay. Okay, this is the same table that I cut only this part of it. So we have around, for the visual inspection alone, there will be around, let's see, for supervising station alarm systems, for in-building fire emergency voice and alarm communication equipment, there is a particular frequency. For the batteries that are involved, there is no particular frequency, but you have a specific method on how to do it and what all actions the maintenance team has to do to ensure the system is in place. So when based on the manufacturer recommendation, these points have to be checked. Then the primary power supply, and then remote annunciators, notification appliance circuit, power extenders. These are all different components of a fire alarm system, which you may and or may not have based on the scale of your system, of what is designed. Maybe if it's for a smaller building, maybe you will not need all of these equipment, but if it's a bigger scale, the equipment that is installed will vary. So based on the BOQ, what is installed, you will have to refer to these particular items, what are installed, and identify what is to be done. So this is one of the important points, point number 17, where initiating devices on what frequency you need to check them. If you look at air sampling detectors, these are semi-annually. Duct detectors, these are all smoke type of detectors. These are semi-annual. And if you look at manual fire alarm boxes, so every 6 months, these devices need to be checked. Smoke detectors, semi-annual, beam smoke detectors, semi-annual, all semi-annual. And then comes notification appliances. Again, audible appliances have to be checked semi-annual. The location has to be checked. If the location has been changed, it has to be updated within the drawing after approval from the HG. So these are points which we need to see what is the installed system, and we need to see what is the frequency with which we need to do it. In another, there's another way to look at it. We are talking only about an installed system currently. If we are going to commission a new system or design a new system, in that point when we are doing installing a particular system, this needs to be notified in the maintenance schedule, as in at what frequency these equipment need to be maintained at. That is one way to ensure that the system is always healthy at the design phase itself. Same thing, when we go from inspection on to the second point, which is testing. For the testing, again, for all of these equipment that we discussed, as in for the control unit, for the notification appliance devices, for the initiating devices, we have a specific methodology on how to test it, and these checkpoints have to be verified, and if there is any variation, the maintenance has to be done to rectify it to function as per how it was approved by the AHJ. And if the AHJ did not have a particular recommendation, it should follow what Nfpa is stating here. So I'm not going back onto the table for testing, because again there'll be a lot to see. But if we just want to refer, we will see where the table is. If it is in Nfpa 72 2022, you'll find it on page number 92. The table is 14.4 3.2 for testing, where it mentions for different ways to test the system and the periodic frequency as well. These are all same to what we saw earlier, but because the testing is mentioned here, you will have a detailed methodology on how to test this, and it will also refer for if you have, see, this is showing an engine driven generator. So if something like this is connected to the Fairlamp control unit, you need to follow the Nfpa code which is governing a generator or a diesel driven engine. Or for example, if you have a pump, there is a separate Nfpa code. If you have a power supply unit, you have a separate Nfpa code, which is, for example, C. You can find it over here. So these are all cross-reference, because each system has its own detailed way to know how to maintain the system. Okay. So we will just say that the way that we can understand how a system is to be tested, you identify what system is installed in your facility. You go to the Nfpa 72, go to the table, you check for the system as what part of component you have as per your DOQ, and then you cross-reference that to what frequency it needs to be tested and the methodology it is to be done. As for the third part of ITM, that is inspection, testing, and then maintenance, every system has its own way to be maintained. So Nfpa 72 always recommends to maintain the system in accordance with the manufacturer's published instructions. So if a smoke detector, even if it is a point, for example, if you have a point smoke detector, which is what you normally see in your houses, each manufacturer might have a different way to maintain the system on how to carry out the maintenance. So just because your maintenance technician knows one equipment doesn't mean that is the way that the other one has to be done. So if he or she is going to do the maintenance on the system, they have to follow the manufacturer recommendation. And the frequency of maintenance of the system equipment shall depend on the type of equipment and the local ambient condition. So the type of equipment is like what we see in the table. We see like notification appliance devices, and you'll have a subcategory as in what type of device are there, and that will have a type of frequency on when it should be maintained. But this is also that comes into a big factor, as in the local ambient condition. If you have generally smoke detectors, normally it is said semi-annual. For example, in Qatar, during the hot season, where the winds are also sometimes high, you have a lot of dust being pulled into open doorways, and you have a lot of smoke detectors which are fixed near to the doorways. So the ambient condition of the smoke detector at that particular location is not the same of what you will have in a different country, in a different location where there is less dust. So based on the location it is actually fixed, we need to modify the frequency. Same thing when it comes to the cleaning of the system equipment. Again, like these detectors, for example, like I said, if there is more dust, these detectors are prone to more dust or false alarms, so we need to increase the frequency of cleaning for this. And there will be certain devices, for example, which are after the activation of alarms, which need to be reset or rewinding needs to be done. So it is mandatory as per maintenance that once any detector goes into an alarm, it should not be left in that condition. It should be reset so that after each test or alarm, you have the system functioning back to normal. And this is another portion of the fire alarm control unit, wherein, like I said, you have elevator controls, the automatic relay of any fire signal to a central command, or the ASJ's fire control, wherein they also get notified of the fire being initiated. So these are not necessary for every systems to have it, but if you have a particular design wherein these are relevant, then the application of whatever relay contact relays, as in for whatever you, I think I'm telling it wrong, I'll rephrase it. If you have an alarm and you have particular systems like an elevator or smoke ventilation fans, you need these signals to trip those systems so that they don't create a further hazard. In the cases of smoke ventilation fans, it should activate the systems. For HVAC units which are pulling in air from outside, you want the air to be cut off to ensure that the fire is not being fed with additional air. So there are different ways to control the fire, and also these same systems can also give signals towards suppression systems as well, wherein like you have FM200 systems, you have dilute systems. So these kind of systems wherein you give the signals for these systems to activate as well. So these are certain emergency control functions which are part of the FA and the fire alarm control unit, which are based on the facility that you're working on. Now this is something that I would advise for somebody who is overseeing any maintenance contractors or a maintenance team itself. So when you have a fire alarm system, the ASJ normally they will require you to submit a cause and effect or an input-output matrix. So what an input-output matrix shows clearly will be, it will have an input. For example, you can see input in number 5. The basement elevator lobby smoke detector has activated. This is the input, as this is the cause. And you see the up on the top side, these are all the system output, which are the effects. So when the basement elevator lobby smoke detector gets activated, it will automatically initiate the notification appliance circuit, one, which is maybe a horn, a set of horns, and this might be a set of strobe. Then what is the next function? You see this, the elevator is recalled to an alternate level. Why is that? See, you have the fire or the smoke detected in the basement. So you don't want the elevator to be sent to the designated level, which is normally the ground level or the basement. So what you want to be doing is you want to send it to an alternate level. If you look at here also, the first elevator lobby, first floor, it is also not sending it to the first floor because this is near to the hazard. It chooses an alternate level. If the fire is in a different location, second or third or whatever different location, it is sending the elevator to a designated level, which is probably the ground floor or the basement, where the people can be easily evacuated from. In certain cases, you will have maybe when the smoke ventilation fans additionally within the elevator itself, which is activated to run, so that there is no collection of smoke within that compartment. So it's not just that these inputs that will be there for a fire alarm system. You'll have smoke detectors, you will have heat detectors, manual call points. There are a lot of inputs, like we discussed, that will come as input devices, initiating devices. So all of those, when you're doing a function test of this whole system, this is the reference that you have to go to, because your whole system is designed and that is all reflected within the cause and effect matrix. And when the person is testing a particular smoke detector, you know what all actions are supposed to come. If these don't function as depicted within the cause and effect matrix, then the system has to be checked where the flaw is. Maybe there is a connection break, maybe the system, the relays are not functioning properly, maybe the fire alarm control panel itself has to be programmed to, if it's an iterable system, maybe the programming itself is wrong. So there are a lot of ways the system can be wrong. So this is where you need to go when an actual testing is taking place to see the effects that are there as per the design. So when these effects are all in place and they're all functioning perfectly, that means the system is functioning healthy. So I think yeah, I think we have covered most of it. So I'll hand over to Julie.
Thank you for that presentation. We do have some questions for you here. The first one is from Paolo, who's asking, could we get a copy of Nfpa 72?
I do have a copy of Nfpa 72 2022, but the actual way to come around it is this is supposed to be purchased. So I need to check if I can share it, and I will get back to you on this.
Okay, thank you. And then the next question is, do we install pressure switch and water flow systems simultaneously or individually?
Can you repeat the question?
Yeah, well, it's in two parts. It said, do we install a pressure switch and water flow switch simultaneously or individually can they function? They can function.
They can function both. You can install a pressure switch independently as well as along with a water flow switch. Again, it comes around to what your HG recommends. So if your HG has a guideline which says that you need to have a water flow switch, which is the mandatory thing, and they're not mentioning anything about a pressure switch, then you have to follow what the HG says, as in you go with the water flow switch. Sometimes your HG might recommend having a pressure switch as well because they consider the system needs a particular pressure to function at its optimum. If the HJ recommends that we need to go with both. And as per the question, yes, you can install both in the same line.
Okay.
And Julie, going back to the first question by Paulo, NFPA, the latest editions, even if you don't get it purchased, you can check them directly on the site.
Oh, that's really useful. Thank you.
You can go through it directly on the site where you can go through the code.
Okay, thank you. So that should answer Paolo's question. He said, copy that, thanks. So then we've got a question from Stephen. He said, knowledgeable presentation, sir. My question is, since you said there is nothing like a false alarm, so do we classify all triggered alarms irrespective of the source or cause alarm as a real alarm? Does that make sense? Do you want me to read that again?
No, that is perfectly questioned. Yes, every single alarm that we have is a genuine alarm, irrespective of what the source is, irrespective of anything, unless or otherwise it is specifically mentioned within the public addressal system that a drill is going on and you do not have to take any action. If there is anything like that, yes, you do not have to take any action until they notify further. Otherwise, any alarm without any prior notification or anything has to be considered as genuine.
Okay, thank you. That's very comprehensive. So we don't have any more questions at the moment. Deepu, do you have any questions?
No other questions from my side. Actually, it's a really wonderful presentation. I'm so happy that Jawahir found some time to deliver this topic over here in our meeting. So thank you, Jawahir. Thanks a lot.
You're welcome.
Yeah, thank you very much for doing this evening's presentation. We do appreciate it. I'd like to thank everyone else for attending this evening. As usual, the presentation will be uploaded onto the IIRSM YouTube channel within the next couple of days, and I'll also put a post out on the LinkedIn page to tell people where it is. I've just seen one more question. We'll make this the last one. You have mentioned something about cybersecurity in Nfpa 72 ?
Yes. So this is also new to me because I was following Nfpa 72 2016. So if you look at the this part, yeah. In 2016, chapter 11 was reserved, so nothing was updated in chapter 11. So right now they have brought up cyber security, and I have actually not gone through it, so I will need some time to refer it and update you in detail.
Last highest
But it's very little, like wherever required by governing laws, codes, or standards, or other parts of this code, cyber security shall be provided for equipment, software, firmware, tools, installation methods, physical security of and access to equipment, data pathways, testing, and maintenance. So this is all that has been added. So there are reasons also why this has come into place, because if you look into the oil and gas sector, we faced a lot of hacking issues. Hacking issues as in the control systems itself were hacked. There were instances like within Ukraine and a couple of other countries wherein the systems were hacked, and the hackers were able to take control of the plant itself for a period. So to overcome this, there are certain ways that we have come around it, as in hard switches, wherein somebody who has to have access to the field device needs to go there in person, and he has to activate a field switch. So only then he will have access to this particular equipment. Otherwise, he cannot do any maintenance without being at present on site. So through the system, like through programming and all, you will not be directly be able to access the system. This is one counter mechanism which we have come through, but there is not much detail other than only this part where you see the cyber security being mentioned.
Thank you. That was really comprehensive, especially when you hadn't read it yourself yet. Okay, so thank you so much, and thank you everyone for attending. I'd like to wish you a good evening, and we hope to see you at next month's webinar. Thank you, everyone.
Okay.
Thank you all, and see you on the next webinar, face to face and online as well. And thank you, Jawad. Thanks a lot.